Okay, this is the revision sort of session or lecture on circular motion for separate physics in year 11. A brief idea of what we're going to cover on the checklist is, first of all, what is circular motion? Second, how do we actually describe something that is undergoing circular motion? This should lead us nicely onto the idea of the force involved in circular motion, which is a force called centripetal force. And then we need to consider what affects the size of this centripetal force, and finally, just in case you need some reminder of what exam questions might be on, we'll look at some simple examples of centripetal force. Okay, so what is circular motion? Any of the images that you can see on screen, whether it be someone throwing a hammer in a sporting event, or a train going around a track, or something that you will not be able to see, but an electron orbiting a nucleus of an atom. All of these things are travelling in a circle. So quite simply, what is circular motion? It is an object that is moving in a circle. We need to go just a little bit further than that though. So let's just think about what an object moving in a circle is doing. If you imagine a motorbike drives around a corner at a constant speed, we need to think about its direction. Now, its direction is constantly changing. So even if the motorbike is travelling at a constant speed, then the direction that it's going in is constantly changing. If you remember from year 10, your definition of acceleration is when velocity is changing. Now, velocity involves speed as well as direction, so it's speed in a certain direction. So something going in a circle is undergoing a constant change of direction, even though its speed is constant. Now, this acceleration is towards the centre of the circle in which it's turning. So this is almost where the motorbike is trying to get to. I always like to think of that. It's sort of, if you look on the diagram here, it's where this purple arrow, if this motorbike was going round in a direction like this, then it's almost accelerating towards the centre of this circle. Now, the velocity is always what we would call in a direction which is along a tangent to the circle. So a tangent means if you take a straight line off the edge of a circle, if I try and show this on the diagram now, again, if you took a straight line there, or a straight line here, or indeed where it is here, this, if you pause it and then carry on in a straight line, that is what we mean by a tangent to a circle. So when an object moves in a circle, its velocity is always along a tangent to the circle. But if you imagine, it's constantly changing. Because of this, we know that it's accelerating, so this change of velocity is towards the centre of a circle. Because it's constantly changing, as we've just said, we know that the object must be accelerating. So a constant change of velocity means that it must be accelerating. So something that is accelerating, you know that there must be a force, and this force is called centripetal force. This is our second of our main ideas.